Okay, this project looks at the reuse potential of mass timber construction using a 10-story shake table as case study. Many of you are probably familiar with this structure, constructed and tested at UC San Diego's shake table facility, and pictured here being partially deconstructed from 10 stories down to 6 for further testing. The lessons learned from that deconstruction and also the reuse of those elements is in a separate effort. Our starting point for this project is going back to the extensive design documentation that existed, including 3D modeling. And the structure is unique not only for its full height rocking walls, but also for the types of mass timber elements used particularly in the floor plates. From a reuse perspective, those extend to different panel geometries and steel connection zones based on those material types. Zooming in on one of the CLT floor plates here, you can see the panels that make up that floor diaphragm, some size differences and geometry irregularities that we're contending and are constraints for the reuse of those elements. Layered on top of that, and we had to actually put this into the 3D model, information about the fastener zones, different insertion angles, and in particular, whether those fasteners extend above or below the center line of the panel. And that's our primary criteria for some grading that I'll show in a second. So in life cycle analysis, we're beyond end of life here, focused solely on the reuse of this material, but instead of stopping at the fact that this is a reusable material, we're asking some additional questions as to how that material might get reused. So first off, grading, and these are big categories of regrading these materials. And we're looking at criteria both for the visual characteristics of that material and also structural. And using those fastener zones and that information about fastener penetrations to accomplish both of those for the sake of this case study. Output products, looking at this building not being decommissioned like a structural test specimen in a short term, but much longer lifespan and service life. That some of these could be commodity products, and standardized lengths and widths would be part of that, including some smaller elements like blocks and logs to increase the reuse percentage with including those smaller elements around larger ones, and also having the added benefit of being manually assembled and expanding the market for reused mass timber there. At the bottom, recombining some of those offcuts that are even thinner into potentially new panel core feedstock, using the outer lamella with graded lam stock there as one structural benefit. So the tool that we developed is primarily in Rhino using Grasshopper, and it takes two inputs, those floor panels coming out of the deconstructed building, and one or more selected product types. It does optimize for cutting path, following each of those options through and using the overall waste percentage and quantity of each of those products as the determining factor for optimization. And on the right, after that subpanel cutting stage, there's subsequent cutting stages of those output products. In this case, a 12 by 24 inch block in blue, and then a half block, 12 by 12 in red, from those remainder pieces. That's the premise of the reuse here, and I'll just march through a little example with that CLT floor plate as installed in the building here, getting to the subpanel stage, 94% remaining with some CNC fabrication assumptions. This is including all of those fastener hole zones, removing just those fastener zones that extend beyond the center line of the panel, 61% remaining. And the most restrictive category, removing all of those fastener zones, 42% remaining, just to get to those subpanels before applying the output product. So those values are shown in row 1 here in this table. Row 2, just for the sake of an example, is that smallest element, 12 by 24 inch blocks. A significant drop in our overall reuse percentage, and that comes back up slightly in row 3 with half blocks being cut from there, but still a significant fiber above these percentages in that lowest row available for recombination of new panel core feedstock, for example, of those thins and narrows. Some of it, of course, is sawdust. Just in conclusion here, some mass timber reuse targets for the future. Admittedly, many of these have a longer time horizon based on the fact that our mass timber building stock is quite new and still small. But a tool like this or thinking along these lines can certainly inform current mass timber building design strategies to optimize their components and connections for future deconstruction and reuse. Thanks.